Hi, welcome back. In this video, we're going to talk about slopes of lines and do a little bit of an Algebra 1 review. If you haven't done so already, click the like button and subscribe. Let's get right to it. Alright, so what is slope? Slope is defined as several or multiple things. The rate of change, the steepness of a line, rise over run, all kinds of stuff. What we're going to be reviewing slope as is how to find the slope between 2 points given a graph, and then how to find the slope between how to find the slope between 2 points using a formula for slope. So here with the graph, as you can see on the left, we are given 2 points. We know this point right here and this point right here. We want to figure out the steepness between these 2 points. As you can see, we have the rise represented as how many units upward it's going. So this is 2 units up, and then the run is 4 units to the right. And I'm going to label that here as rise and run. If you can see here in the formula, slope is defined as the vertical change over the horizontal change, or the rise over run. Since we already have these numbers, we're going to write it as 2 over 4. So m equals 2 over 4. Now, since they're both divisible by 2, we can simplify this down to 1/2. So graphically, one way to find the slope is by using the graph and counting the rise over the run. As you can see, this line is increasing, so the slope is positive. If the line were going the other direction, going downward, the slope would have been considered negative. In this example, I'll show you how to find it using the formula. So we have 2 points, A and B. I'm going to first find the location of these 2 points. I'm going to label this one as -2, 3, and this one as 4, -1. Now, as you can see in this formula, I'm going to label one point as the first point and one as the second point, with x1, y1, and x2, y2. And I'm going to do just that with my points. I'm going to label this x1, y1. This is my x1. y1, and then with this other point I have x2, y2. Now that I label my points, I'm going to plug them into this formula. Notice how I'm still doing rise over run by doing the change of y over the change of x. So I'm going to subtract these points. I have y2 minus y1, and I plug them into this formula. So m equals the change of y. So I have y2, which is -1, minus y1, which is 3, divided by the change of x. I'm going to take my x2 coordinate, x2 minus x1. So I have 4 minus a -2. Now, subtracting a negative will simply change this denominator as a positive. So, minus a negative here changes this to a plus. And then I simplify. So on the top I have -1 minus 3. That comes down to -4. And in the denominator I have 4 plus 2, which is 6. -4 over 6, both numbers are divisible by 2. So I can actually simplify this down to -2 over 3. And I can count. I can actually also do this slope on the graph. Notice when looking at this graph, between these 2 points, I'm going to try to do this. Between these 2 points, right, the line is going downward. So the slope, in turn, right, is decreasing or is going down to the negatives. I can check my work by checking graphically the rise over run. I can count the rise over the run to get to this point. Notice how the rise is up 4, and then the run is 6 to the left. Or I can represent that as -6. So rise is 4, 6 is the run. Since this slope is going downward, it would be negative, and that's negative 4 over 6, or negative 2/3. This is how you find it on the graph and using the formula. Now let's talk about how do we compare slopes. Whenever you have two sets of lines or two sets of points, and we want to compare this relationship, we can say that these lines are parallel, perpendicular, or neither. Parallel lines have the same slope. We've discussed before that when you're comparing parallel lines, we have consecutive interior angles or alternate exterior angles or corresponding angles. We have these different angles that determine the relationship between these two lines, right? So when we're talking about the steepness of two lines, what we've said right now, or so far, I can draw a little sketch here on the left. The steepness of these two lines come down to these angles, like corresponding angles. If those two angles have the same steepness or the same degree, then these two lines are going to end up being parallel. Well, if we're not talking about angles and instead we're talking about slope, for lines to be parallel, the slope must be the same. So the rule for parallel lines is the slope is the same. So let's say that you have a line whose slope is a over b. If you want to find another line that is parallel to it, you must have a slope that is the same, a over b. If the slope of both lines is equal, then you have parallel slopes or parallel lines. Perpendicular is when these lines would intersect at 90 degrees. In order for them to intersect at 90 degrees, the slope has to not be the same. In fact, it's got to be opposite. And the rule that we say to describe it is negative reciprocal. And what this means is that if I have a slope of a over b, what I'm going to do is I'm going to flip the slope to b over a. And I'm going to change the direction of the slope. So negative. I'm going to change the sign and flip the fraction. And this is how you would determine if the slopes were perpendicular to each other. So let's try a couple examples. These following two examples I am taking out from our Schoology practice. So if you want to check your work here with me, you feel free to do so. This example here is asking to determine whether or not JK, line JK and PO are parallel lines, perpendicular, or neither. And I'm given the points. So first I'm going to find the slope of JK, these two, and then the slope of PO, and then compare them. So I'm going to do that here. I'm going to do one in red. I'm going to find the slope of JK, then I'm going to find the slope of PO, and compare those slopes. Are they the same? Are they negative reciprocals, or are they neither to each other? So let's try this out. I'm going to first label these points as x1, y1, x2, y2. Remember, my formula is y2 minus y1 over x2 minus x1. And I'm just going to plug in these points. For y2, I have 4. So m equals 4 minus y1. Now, y1 is a negative, so I'm going to subtract a negative 2 divided by x. x2 is 5 minus negative 5. These minus negatives must change to a positive. Subtracting a negative is the same thing as saying addition. So I'm going to change this to plus, and this one as well. So in the bottom in the numerator, I have 4 plus 2, 6, and the denominator I have 5 plus 5, which is 10. Notice how both numbers, the top and the bottom, numerator and denominator, are both divisible by 2. So I can actually simplify this down to 3 over 5 as a slope. This is the slope for line JK. Now I'm going to do the same thing and find the slope for line PO. I'm going to plug it into the formula, find the slope, and then I'm going to compare these two slopes. Are they the same? Are they negative reciprocals, or neither? So let's do that. I'm going to first label these points as x1, y1. and x2, y2. My formula is y2 minus y1 over x2 minus x1. And I plug stuff in, right? y2 is negative 4 minus y1, which is positive 6, divided by x2 is 3 minus x1, negative 3. Again, here in the denominator, I have a minus a negative, which I'm going to change to positive, and then I start simplifying. In the numerator, I have negative 4 minus 6, that's negative 10. In the denominator, I have 3 plus 3, which is 6. At this point, I'm going to divide both the top and the bottom by 2, since they're both divisible by 2. And I have m equals negative 5 over 3. Now it comes down to comparing these slopes. Notice how the slopes, the 3 over 5, gets flipped to 5 over 3. And then it goes from being positive to negative. That is the rule of perpendicular lines. So what do we know about these two lines? They are perpendicular to each other. Sorry about that, that was my dog. So I found the slope of JK, I found the slope of PO, and I compared them. Notice how the slope got flipped and the sign changed. That is the rule of perpendicular. Let's try one more and call it a day. Feel free to pause this video at any time, give it a try yourself, and compare your answers with me. So, JK and PO, are they parallel, perpendicular, or neither? Again, I'm going to do this in colors. First, I'm going to find JK. x1, y1, x2, y2. So, m equals y2 minus y1 over x2 minus x1. Now, if you prefer to graph this, feel free. Grab some graph paper, graph these points, and you can always do this using rise over run. You can always count the squares, rise over run, compare the slopes, and see what you've got. But since I don't have graph paper here, I'm going to use the formula. So we have y2, which is 6, minus y1, a negative 8, divided by x2, which is 1, minus x1, negative 1. The formula says minus the x value, and if the x value is negative, you have to subtract a negative, which means addition. So the top changes to plus, and the bottom changes to plus as well. As I continue to simplify, in the numerator, I have 6 plus 8, which is 14, and the bottom I have 1 plus 1, which is 2. Notice how 14 divided by 2 equals 7. So I can write this slope as 7 or 7 over 1. I'm going to do the same thing with the other formula, or the points for PO. Label these x1, y1, x2, y2, and repeat. M equals y2 minus y1 over x2 minus x1. So let's give it a try. y2 equals 10, subtracting negative 6, over x2, which is 2, subtracting a negative 2. The subtracting a negative is becoming a bit of a pattern here. Minus a negative turns into positive, minus a negative turns into positive. So, in the numerator, I have 10 plus 6. M equals 16. In the denominator, I have 4. Notice how 16 divided by 4 equals 4, or 4 over 1. Now it comes time to compare them. Are these slopes the same, or are they negative reciprocals? In fact, they're neither. These two slopes are not flip and change the sign, and they're not the same. So these lines, they just intersect. They're not parallel nor perpendicular. So we say they're neither. If you feel like this video was helpful, I hope it was, hit the like button, let me know that you've liked it, or leave a comment below. Thank you for coming back to my channel, my few loyal subscribers. If you haven't subscribed already, please do so. I'm going to keep putting videos out for the rest of the year, and subscribing lets you know when I have released a video so that you can come watch it. It sends you a quick email. All right, we'll calculate later.